hydroxides. Number 6, it attacks glass to form sodium triosilicate 4. Sodium hydroxide attack glass. The primary constituent of this glass is silicon 4 oxide. So it attacks silicon 4 oxide to form sodium silicates and liberates hydrogen. And hydrogen becomes liberated in the process. So it reacts with glass to form this compound. Uses of sodium hydroxide and sodium chloride. 1. Uses of sodium hydroxide. It is used to absorb carbon 4 oxide. That is one of the uses of sodium hydroxide. They can be used to absorb carbon 4 oxide because they have affinity, that is likeness, for carbon 4 oxide. 2. For purification of bauxites. They use them to purify bauxites. 3. To refine petroleum. Sodium hydroxide can also be used to refine petroleum. Number 4. For bleaching of cotton textiles. They used to bleach cotton textiles. Sodium chloride. Sodium chloride is simply known as common salt. Preparation. It is prepared by the reaction of sodium hydroxide with hydrochloric acid. Sodium hydroxide with hydrochloric acid, where you have sodium chloride plus water. So the compound of interest, which is sodium chloride, can be prepared by the reaction between sodium hydroxide and hydrochloric acid. Properties. It melts at 80 degrees Celsius and boils at 1420 Celsius. It is not deliquescent, that is, it does not absorb moisture from the atmosphere to form solution. Uses of sodium chloride. It is an essential part of human diet or of our diets. 2. It is used as a food preservative, just like the case of adding salt to fish to prevent spoilage. It is also used as a raw material in chemical industry. Chemistry of tetraoxosulfate 6 of sodium. Preparation. By neutralization of dilute tetraoxosulfate 6 acid with sodium chloride. A2SO4 plus sodium chloride gives Na2SO4 plus HCl is 2. So this salt is our salt of interest, which is produced or prepared by a reaction of tetraoxosulfate 6 acid on sodium chloride. Properties. Its hydrated form is efflorescent and is known as global salt. When we say a compound is efflorescent, what are we talking about? It means it has the ability to lose some of or part of its water of crystallization when it is being exposed to the atmosphere. And a typical example of this is what is known as global salt. Global salt, which is Na2SO4.10H2O. This is what is known as global salt, which is an efflorescent compound. Uses of sodium tetraoxosulfate 6. 1. It is used in the production of sodium sulfide. 2. It is used as purgative and in the manufacture of wood pulp, glass, and detergents. When you say purgative, what are we talking about? We are talking about the evacuation of the bowel. So it is used to evacuate the bowel. Chemistry of sodium triazonitrate 5 preparation. It is prepared by a reaction of sodium hydroxide and triazonitrate 5 acid. Sodium hydroxide plus triazonitrate 5 acid, where you have the formation of sodium nitrate, which is our compound of interest, plus water in the process. Properties. It decomposes on heating to give dioxonitrate 3 and oxygen. This decomposes on heating to give dioxonitrate 3 and oxygen. The 3 and oxygen. So when this is heated, you have dioxonitrate 3 and oxygen gas being produced. Uses. It is used as nitrogenous fertilizer. 2. It is used in making triazonitrate 5 acid. 3. It is used in making gunpowder. Chemistry of sodium triazocarbonate 4. It is also known as soda ash, that is the anhydrous form. And the decahydrate is known as washing soda. Laboratory preparation of sodium triazocarbonate 4. It is done by passing carbon 4 oxide through sodium hydroxide. 2 moles of sodium hydroxide aqueous plus CO2 gas. Then you have sodium triazocarbonate 4 aqueous plus water liquid. So this is the laboratory preparation where this carbon 4 oxide is passed into sodium hydroxide to give sodium triazocarbonate 4 and water as the byproducts. Properties. Action of heat on it and its hydrogen carbonates. Sodium triazocarbonate 4 on heating, it does not decompose. Therefore, it is stable to heat, but its hydrogen carbonate, when heated, gives sodium triazocarbonate 4 plus water plus CO2. So this on heating is very stable. It does not decompose on heating. While its hydrogen carbonate give the corresponding compound water and carbon 4 oxide. That is the difference between this and this. This is stable to heat, while this one decomposes to this water and carbon 4 oxide. 2. Washing soda is an efflorescent substance. When we say efflorescent, we are talking about compounds that when they are exposed to the atmosphere, they lose parts of their water of crystallization. 3. It reacts with acid to liberate carbon 4 oxide, and that is one of the properties of this. When they react with acid, pick any acid, whether hydrochloric acid, so it gives sodium chloride, 2 moles of it, plus water, then plus carbon 4 oxide. So acid reacts with this compound, which is a base, to give salt, water, and carbon 4 oxide. 4. Both sodium and sodium hydrogen trouser carbonate are white crystalline solids. Uses of sodium trouser carbonate 4. 1. It is used extensively in the manufacture of glass and as water softener to soften water. 2. It is used in detergents and in manufacture of sodium hydroxide. 3. It is used as an analytical reagent. It is used to perform analysis in the laboratory. 4. It is used to standardize acid. Chemistry of potassium. Potassium is also a member of the group 1 elements. Compounds of potassium are of great importance in agriculture as fertilizers. Preparation. It is prepared by the reaction of potassium hydroxide with dilute hydrochloric acid, and that is also known as acid-base reaction to give salt and water. Compounds of potassium. The first is potassium fluoride. Its mineral is known as carnallite. Uses. It is used as a fertilizer and in the manufacture of potassium compounds. The chemistry of potassium compounds are not as vast as that of sodium. Potassium tetraoxosulfate 6. Preparation. It is prepared by the reaction of potassium hydroxide